In the last video, we discussed about the voltage current characteristics of resistor and inductor. Now in this video, we discuss about the voltage current characteristics of capacitor.
So this proportionality constant, we call it as capacitance C. This we call it as a capacitance C, right? So, and from this equation, what is C here? C, we can write it as Q by V, charge per unit voltage. Also, unit charge per unit voltage is called as a capacitance. Now, we know that the current relation between the current and charge, relation between current and charge is given by I is equal to dq by dt. So the change in charge is called as current. The change in charge is called as a current, and that change in charge we represent with a differential operator dq by dt. So therefore, the current I is equal to dq by dt, and we know that. And what is q? Q already we have derived it is equal to cv. Now, when you substitute q is equal to cv in this equation, I is equal to d by dt of CV, where C is a constant. Since it is a proportionality constant, therefore you can remove it from the derivative term from, and you can write it like this. Therefore, your current I is equal to C into dV by dt. Your current I is equal to C into dV by dt is the one relation in case of a capacitor. So this current I call it as a current in capacitors. All right. Therefore, for the panel plate capacitor, the capacitance is shown by the capacitance general. If you consider a parallel plate capacitor like this, right, which has a dielectric medium inside it. So this is a dielectric medium inside it. So, and this plates has an area of cross section of A, and these plates are separated by a distance d if they are, and if epsilon is the permittivity of the dielectric medium. Epsilon is the permittivity of the dielectric medium. Then the capacitance is given by epsilon A by d. This is you have studied in case of physics. So in case of parallel capacitor, if A is a area of cross section of the plate and D is the distance separated by these two plates, and if epsilon is the permittivity of the dielectric medium, then it is called as uh, capacitance, right? Then energy stored in the capacitor. Obviously, so we already studied that the capacitor stores a static energy, right? So let us consider a V voltage applied across the capacitor at this instant, and W be the joules of work done. So therefore, the work done is given by W. So it is joules, and will be done transferring one charge of 1 coulomb of charge from one plate to another plate. So therefore, if small charge dq is transferred, then the work done is equal to dw is equal to v into dq. And from this one, if you integrate on both the sides, then you will get as you will get as w is equal to integral 0 to v and c v dq. All right. So and from this one, if you integrate it with the finite limits like this, you will get the W is equal to half CV square. Therefore, this is the formula for energy stored in a capacitor. So from this one, what we can infer here it is your capacitor stores finite amount of energy. And in place of V also you can write V is equal to Q by C, right? We have a formula Q is equal to CV, and from that V is equal to Q by C. And then if you substitute this V is equal to Q by C in this equation, then you will get as W is equal to half Q square by C. So that is this is in terms of charge, and this is in terms of the applied voltage. So these two formulae represent the energy stored in a capacitor. All right. Now let us look at the properties of a capacitor. So it stores energy in the form of electrostatic field, as I mentioned earlier. The current in the capacitor is zero the current is zero if the voltage across it is constant. That means if you look at the expression earlier for current, I is equal to dq by dt or C dv by dt and రాసాం మనం ఆల్రెడీ ఇందాక చేసాం. Suppose if V is constant, if V is constant, suppose if V is constant, then what is dv by dt? dv by dt becomes 0 and therefore your I becomes 0. That is current will become 0. That is అదే ఇక్కడ చెప్తుంది. The current in a capacitor is 0 if the voltage across it constant. ఎందుకు derivative of that voltage becomes 0. That means the capacitor acts as open circuit. ఎప్పుడు కరెంట్ జీరో అవుతుంది when there is an open circuit like this, when the circuit is opened like this is an open circuit అని అంటాం. So current, what is the current in this one? There is no closed path for the current to flow, therefore current would become 0. So this will happen only when you apply the fixed voltage or a constant voltage. Constant voltage means what? DC అని అర్థం. So from this discussion what we can infer here it is the current in a capacitor is 0 and hence your capacitor acts as a open circuit when a DC voltage is applied. It acts as an open circuit when DC voltage is applied, right? That's it. That is one. And a small change in voltage across a capacitance within zero time and infinite current through the capacitor, which is physically impossible. ఎందుకు? Suppose if you change మనకు formula అంటే I is equal to C dV by dt. In this one, if dt is 0, అదే ఇక్కడ చెప్తుంది within zero time అని అంటే zero time అంటే dt change in time is 0 అంటే within 0 seconds if you increase or decrease the voltage, then anything by 0 will leads to infinity. That is current leads to infinite current through the capacitor when a small voltage within 0 time you farad. This is another important property you must know. So the capacitor does not allow sudden change in voltage. So it is called as a voltage stiff element అని అంటాం. ఎందుకు సడన్ వోల్టేజ్ చేంజ్ ఇన్ వోల్టేజ్ అది అలో చేయదు? ఇది బికాస్ ఆఫ్ దిస్ ఫ్యాక్ట్. ఎందుకు సడన్ వోల్టేజ్ ఇన్ చేంజ్ విత్ జీరో టైమ్ విల్ లీడ్స్ టు infinite current and therefore your capacitor does not allow sudden change in voltage and therefore it is called as a voltage stiff element. Capacitor is called as a voltage stiff element, whereas your inductor called as a current stiff element అని మనం నిన్న క్లాస్ లో చెప్పుకున్నాం. Then a capacitor behaves as a short circuit just after the switching across the DC voltage. అది కెపాసిటర్ ఇది తర్వాత డిస్కస్ చేయొచ్చు. కెపాసిటర్ will acts as a short circuit immediately after the DC source is applied. DC voltage when immediately అప్లై చేసిన వెంటనే షార్ట్ సర్క్యూట్ కింద ఉంటుంది. తర్వాత it acts as a open circuit అనమాట. So the capacitor can store a finite amount of energy even the current through it is 0. అదే కదా అనుకుంది capacitor. What is the energy stored in a capacitor? Half CV square. If you suppose if V is constant, a constant voltage is applied, then what is IC? IC becomes 0 because of this fact. dV by dt, C dV by dt. But though the current is 0, the capacitor stores a finite amount of energy. A pure capacitor never dissipates energy but only stores energy. Hence it is called as a non-dissipative element అని అంటాం. So a pure capacitor does not dissipate the energy, it stores the energy. అదే మనం చూసుకుంది pure capacitor, ideal capacitor. But if you take a practical capacitor, because of the plates resistance, capacitor plates ఉన్నాయి కాబట్టి వాటి resistance మూలాన they offer some resistance and therefore due to that is internal resistance, the capacitor may some dissipate some energy because of its internal resistance. So now this is about the properties of the capacitor. Now if you suppose if V is constant, a constant voltage is applied, then what is IC? IC becomes 0 because of this fact. dV by dt, C dV by dt. But though the current is 0, the capacitor stores a finite amount of energy. A pure capacitor never dissipates energy but only stores energy. Hence it is called as a non-dissipative element అని అంటాం. So a pure capacitor does not dissipate the energy, it stores the energy. అదే మనం చూసుకుంది pure capacitor, ideal capacitor. But if you take a practical capacitor, because of the plates resistance, capacitor plates ఉన్నాయి కాబట్టి వాటి resistance మూలాన they offer some resistance and therefore due to that is internal resistance, the capacitor may some dissipate some energy because of its internal resistance. So now this is about the properties of the capacitor. And after uh, discussing the passive elements, namely as resistance, inductance, and capacitance, and their voltage current relations also we have discussed. So in case of a resistor, what is the voltage current relationship? V is equal to IR, that is Ohm's law, that right. And in case of an inductor, what is the voltage current relationship? V is equal to L di by dt. In case of an inductor, the voltage and current relationship. And in case of a capacitor, what is the voltage current relationship? I is equal to C d by dt, or V is equal to 1 by C integral I dt. Both are same, one and the same, right? So this is the voltage current relationship in case of a passive elements, namely resistance, inductance, and capacitance. And whereas in case of an inductor acts as a short circuit for constant voltage. When you apply a DC voltage, inductor acts as a short circuit because uh, yeah, di by dt, that is when you give a constant current, then when you give a constant current, obviously the derivative of that will become zero. The derivative of that will become zero, and therefore voltage is zero and it acts as a short circuit. Voltage zero means is a short circuit. And whereas in case of a capacitor acts as a open circuit for DC voltage. Since I is equal to C dV by dt, when you apply a constant voltage, then dV by dt becomes zero and current becomes zero. Therefore, zero current in any circuit represent as a open circuit. All right. So this is about the properties of resistance, inductance, and capacitance and their voltage current relationships.
Thank you, one and all. We will meet in the next session.